question we are given an inequality in a logarithm. We are told that log of a square minus 16 to the base 10 is less than or equal to log of 4a minus 11 to the base 10, and we are required to calculate the solution set. That is, we are required to calculate what are the values of a which satisfy this given inequality. Before we look at the inequality, for the logarithms themselves to be defined, the arguments of the logarithms, both of them have to be positive. So we want a square minus 16 to be greater than 0, and we want 4a minus 11 to be greater than 0. Next, when you want this inequality to be fulfilled, if you are looking at a logarithm which is of the form log of a to the base c is less than or greater than, say, log of b to the base c. If the value of c is greater than 1, that is, if the base is greater than 1, then a has to be less than b. That is, the sign of the inequality will not change. But if the base is, say, less than 1, then the sign of the inequality is reversed. That is, in this particular case, a will be greater than b. Over here, we are given an inequality and the base is 10, which is greater than 1. So, if you are removing the logarithms, it would imply that a square minus 16 will be less than or equal to 4a minus 11. That is, the sign of the inequality does not change. But say in this particular inequality, if you are given log of, say, a to the base 0.5 is less than log of b to the base 0.5, then it would imply that a is greater than b. Anyway, here this is the inequality that we have, that a square minus 16 is less than or equal to 4a minus 11. So a square minus 4a minus 5 is less than or equal to 0. This would imply that a minus 5 into a plus 1 is less than or equal to 0. This is a quadratic equation. The roots of the quadratic equation are minus 1 and 5. As the product is less than or equal to 0, this would imply that a has to lie between minus 1 and 5. This is the solution set if you are going just with the basis of the given logarithm. But we also want a square minus 16 to be greater than 0. This is also a quadratic equation which is of the form a minus 4 into a plus 4. The roots of this quadratic equation are 4 and minus 4. And here the inequality is greater than 0. Earlier it was less than 0. If it is greater than 0, then the value of a should not lie between the two roots. That is, either a is less than minus 4 or a is greater than 4. The third condition is that 4a minus 11 is greater than 0. So a is greater than 11 by 4. You want all these three conditions to be satisfied. That is, a has to lie between minus 1 and 5, a has to either be less than minus 4 or greater than 4, and a has to be greater than 11 by 4. All of these will be satisfied only if a belongs to 4, that is, a is strictly greater than 4 and less than or equal to 5. So the correct answer is option D.